Have you ever had that feeling that the future is happening right now? Well, that's exactly what's going on with quantum computing. This isn't just a faster computer. We're talking about a completely different way of thinking about computation itself. It's a whole new dimension. So let's jump right in.
So here's the big question, right? Is this whole quantum thing just some far-off sci-fi dream, or is it really the next massive tech revolution? We're going to break down how this went from a wild idea on a chalkboard to a real, tangible technology that is absolutely changing the world as we speak.
All right, so what's the secret sauce here? What makes a quantum computer so quantum? It all comes down to one tiny but incredibly powerful component, the qubit. If you can wrap your head around this, you're going to understand the whole quantum game.
Look, the computer, you're watching this on, your phone, everything. It all runs on bits. And a bit is super simple. It's like a light switch. It's either on, which we call a 1, or it's off, a 0. That's it. But a qubit is where things get really weird. It's more like a dimmer switch. It can be on, it can be off, or it can be in this strange, shadowy space in between, holding both 0 and 1 at the exact same time.
This absolutely mind-bending ability is a real thing in quantum mechanics, and it's called superposition. It's the magic trick that lets a single qubit be in multiple states at once. Now think about the power that gives you. Instead of trying to solve a maze by going down one path, and then another, and another, a quantum computer can explore every single possible path all at the same time. It's an unbelievable advantage.
Okay, that's the theory. It sounds cool, but is anyone actually building these things? And the answer is a resounding yes. This stuff is no longer locked away in some university basement lab. It's moving to the cloud. And believe me, the biggest names in tech are all in.
433. Just look at that number. That's the number of qubits in IBM's Osprey processor. Now, to give you some perspective, the power of a quantum computer grows exponentially with each qubit you add. So we're not talking about just making things a little faster. We're talking about a complete explosion in raw computational power. And you can bet IBM isn't the only one in this race. Not by a long shot. We're talking about a full-on quantum arms race here. Google, Microsoft, Amazon, all the heavy hitters, the titans of tech, are pouring billions of dollars into this, betting that quantum is the undeniable future of computing. And you know what? Here's what might be the coolest part of all. You don't need to be a multi-billion-dollar corporation to get your hands on this tech anymore. These incredible machines are now accessible through the cloud. This is a huge deal. It means researchers, developers, scientists, pretty much anyone with a good idea can start experimenting with the very technology that's going to shape our future.
So we've got all this incredible power, but what do we actually do with it? Forget about running spreadsheets faster or getting better frame rates in video games. We're talking about solving problems that are literally impossible. I mean, mathematically impossible for even the world's most powerful supercomputers today. Seriously, the potential applications are just staggering. Imagine designing life-saving drugs by simulating exactly how they'll work in your body, down to the last molecule, or discovering brand new materials to build hyper-efficient batteries. This is the kind of tech that could revolutionize finance, create a whole new generation of AI, and even give us new tools to fight climate change. But with all this power comes a really serious risk. A powerful quantum computer could, in theory, become a universal skeleton key. It could break the encryption that protects basically our entire digital lives, from your bank account to government secrets. But here's the flip side. That same quantum power could help us create new, truly unhackable forms of communication. So it's this epic, high-stakes race between the code breakers and the code makers. All right, let's be real for a second here. As exciting as all this is, building a large-scale, fault-tolerant quantum computer is not easy. In fact, it's one of the most difficult engineering challenges humanity has ever taken on. There are some massive hurdles still in the way. You can basically boil it down to 4 gigantic challenges. First, you've got error correction. Qubits are insanely fragile. The slightest vibration or temperature change can throw off a whole calculation. Second is something called decoherence, which is just a fancy way of saying that qubits can just lose their quantumness and stop working. We have to keep them stable. Third is scalability. Going from a few hundred qubits to millions, that's a monumental engineering leap. And finally, you can't run old software on a new type of machine. We need to invent a whole new way of programming, new quantum algorithms to actually tell these things what to do. But let's look beyond those challenges for a moment. Let's assume we solve them, because scientists are making progress every single day. What kind of world does that create?
What does our society look like on the other side of this revolution?
We are talking about a fundamental transformation, a future with a healthcare system that designs medicine specifically for your DNA, a future with brand new industries and economic opportunities that we can't even imagine today. You know, this isn't just a new gadget. It's like being handed a new set of rules for the universe, a new lens to see everything from the smallest particles to the fabric of the cosmos.
So, you see, the question really isn't if this quantum future is coming anymore. The question is when. And as this almost unimaginable power moves from the realm of science fiction into concrete fact, we all have to start asking ourselves, are we ready? Are we ready for the breakthroughs, for the disruptions, and for the incredible responsibility that's going to come with it? It's a lot to think about.